Hello students, welcome back to my channel. Today's question: the mass of oxygen that would be required to produce enough CO which is completely reduces 1.6 kgs of Fe2O3. Atomic mass of iron also the given 56 grams. So this is the question. Now coming to the given information, the mass of oxygen is required. So weight of or mass of oxygen required. So question mark, this is the, so mass of oxygen we have to calculate to produce enough CO to which completely reduces the Fe2O3. So Fe2O3 is reduced by the carbon monoxide. Then what are the products? So iron Fe2O3 is reduced by the carbon monoxide. Reduction means what is that? Removal of oxygen. So remove the oxygen, then iron will be formed, metal will be formed, and this CO becomes like a CO2. So this is the these are the products. Now balancing the equation, Fe2O3 plus CO gives rise to Fe plus CO2. So two irons are there. So write down two irons. Next, here 3 oxygens, here 1 oxygen, here carbon. So put down here 3 moles of carbon monoxide. Then how many carbons are there? 3 carbons are there. So here also write down 3 carbons. Then how many oxygens? Here 3 oxygens, here 3 oxygens, totally 6. So 3 2s are 6. So this is the balancing equation. So from this equation what we can say, 1 mole of Fe2O3 reduced by how many moles of CO? 3 moles of CO. Reduced by 3 moles of CO. But here Fe2O3 weight they given, they didn't given the mass. So we have to convert it into the mass. So 1 mole of Fe2O3 weight how much? 2 Fe2O3 molecular weight if you are calculating. So 2 irons, each iron is the 56. So 2 irons means 112, and 3 oxygens, each oxygen is the 16, and 3 oxygens means that is the 48. So totally this is the 160 grams. So 1 mole of Fe2O3 means what is that? That is the 160 grams of Fe2O3 is reduced with how many moles of CO? 3 moles of CO. Now they are asking how many moles of they given Fe2O3 weight, how much they given? 1.6 kg. So 1.6 kg means how many grams into 1000 if you're done, then you will get the 1600 grams of Fe2O3 is reduced with how many moles of CO? How many moles of CO we can calculate. Why? Because from the equation what we can say, 1 mole of Fe2O3 is reduced with 3 moles of CO. But the given Fe2O3 in weights they given. So 1 mole of Fe2O3 weight means how much? That is 160 grams. So 160 grams of Fe2O3 is reduced with 3 moles of CO. 3 moles of CO. But they are asking for 1.6 kg they are asking. So 1.6 means how much? 1.6 into 1000, then 1600 grams of Fe2O3. How many moles it is reduced with how many moles of CO we have to calculate. So now do the crisscross. So then question mark equal to 3 into 1600 by 160. So that is how many moles is required? 30 moles of CO is required to reduce the 1.6 kgs of Fe2O3. 1.6 kgs of Fe2O3. So this is that how many moles of CO is required? 30 moles of CO is required. So now what they're asking, this CO is produced, this how much enough is CO is enough for to reduce the 1.6 kgs of Fe2O3, that is produced from oxygen. how much amount of oxygen this CO is will be formed, they are asking. So this oxygen is combines with carbon, then CO will be formed. So when you are doing the balancing equation, this is 1 by 2, half O2 gives rise to CO. So now from this equation what we can say, half mole of O2 is required to produce the 1 mole of CO, 1 mole of CO. But to reduce 1.6 kgs of Fe2O3, how many moles of CO is required? That is the Fe2O3, that is 30 moles of CO is required. 30 moles of CO is required. So here half mole of O2 is required. From the equation what we can say, half mole of O2 is required to produce 1 mole of CO. Then we need 30 moles of CO. Why? Because this 30 moles of CO is enough to reduce the 1.6 kgs of Fe2O3. Now 30 moles of CO is produced from how many moles of oxygen? So now again do the crisscross, then question mark equal to 30 into half by 1. So 30 into half, that is the 15 moles. So how many moles of oxygen is required? 15 moles of oxygen is required. But they didn't ask it in terms of moles, they are asking about the amount of oxygen. So 15 moles of oxygen is required. So 15 into 1 mole of oxygen weight how much? 32. So 15 32s are, we will get the 480 grams. 480 grams of oxygen is required to produce the enough CO. Enough CO how much? That is 30 moles. 30 moles of CO. Enough CO to reduce the 1.6 kgs of Fe2O3. Fe2O3 we have to reduce with CO. How much CO is required? That CO is formed from oxygen. So this amount they are asking. Oxygen amount they are asking. So 1.6 kgs of Fe2O3 is reduced by the how many moles of CO? 30 moles of CO. So 30 moles of CO is produced from 15 moles of oxygen. So 15 moles means how many grams? 15 into 32, then it is the 480 grams oxygen is required. So this is the answer for this. So once understand the question, the mass of oxygen that would be, so mass of oxygen they're asking, that would be required to produce enough CO, means from the oxygen CO is produced, that CO is reduce the 1.6 kgs of Fe2O3. So for 1.6 kgs of Fe2O3 is reduced by how many moles of CO? 30 moles of CO is reduced. Then this 30 moles of CO is produced by how many moles of oxygen? 15 moles of oxygen. So 15 moles of oxygen means that is the 480 grams of oxygen is required. Thank you.